What we've got here is actually an air conditioning unit, okay, but it uses exactly the same technology as an air to water heat pump. The only difference is that we've got two pipes coming out of here which would usually go onto an air conditioning unit, whereas with an air to water heat pump we'll have a refrigerant to water heat exchanger here, and so we just pass water against the pipes of the hot refrigerant to transfer the heat. But that's the only difference. It's the same technology which is in your fridge, it's the same technology which is in your freezer. When you put your hand down the back of your fridge, sometimes you'll feel it warm, and that's because the heat's been moved from inside the fridge to outside the fridge. So before we take a look at it in there, what we're going to do is we're going to do a couple of little science experiments. Okay, so I've got a bicycle pump here, okay, and what I'd like you to do is take that one, put your finger over the end, okay, give it a few pumps, and tell me what happens.
It's getting warmer.
Okay, that's right. Okay, so what? So just by pressurizing normal air which is around us, okay, it raises its temperature. Okay, so if you increase the pressure on any liquid, okay, it will increase its temperature and eventually turn into a gas, like when you boil your kettle at home. Okay, you boil the water and then that turns it into gas. If you were to pressurize it, it would boil at a lower temperature. So if we pressurize something, it increases its temperature. If we reduce pressure, then we reduce temperature. Got it?
Yeah.
Okay. Right. So the next thing that I want to get across, you notice I've poured a beer. Do like a beer, but that's not the purpose today. It's quite a warm, sunny day. The sun's out. Now this beer was absolutely freezing cold when I took it out of the fridge, and now it's been sat there for probably about 10 minutes. Have a go.
It's got warm.
Yeah, it's warmed up. So what's actually happened there is that, okay, the air surrounding it is warmer than the beer, and so the heat is synced from the air around us into the beer. So if you increase pressure, you increase temperature. And if you've got something at a lower temperature, hot goes to cold. Okay, so if you just remember that hot goes to cold, and increase in temperature means increase in pressure means increase in temperature, reduction in pressure means reduction in temperature. Got it?
Yeah.
Right, okay, so we've understand the science which makes a heat pump work. Now we're going to take a look inside. So I'm going to pull this cover off. Okay, that's one of the major components there. What's that?
Fan.
Okay, yeah, that's right. So we've got a fan. We've got a heat exchanger. Okay, and that's got copper pipes in it with refrigerant inside. Okay, we've got an expansion device there. Okay, which depressurizes the system. We've got a compressor which pressurizes the system. Okay, this is actually an air conditioning unit, but the technology that you're using an air to water heat pump is exactly the same. The only difference is that an air conditioning unit will have either hot or cool gas coming out of these pipes and going to an indoor unit. In an air to water heat pump, we'll just have a plate heat exchanger on there, and we'll have water running one side and hot refrigerant running the other side, and so we heat the water with it. But the technology which is in a heat pump is the same as what is in an air conditioning unit, which is in a chiller, which is in your fridge or your freezer at home. So that's the technology. How does it work? So that fan will be running. Okay, it'll be pulling air across that heat exchanger. As it does so, because the air is warmer than the refrigerant in the pipes, the heat goes from the air into the refrigerant. That is liquid refrigerant. It's increased in temperature. It then goes to the compressor, which pressurizes it. And when you pressurize something, what does it do?
Heats it.
Exactly, it increases its temperature. So coming out of this compressor, we've got super hot refrigerant, which then will come out of this pipe here. Like I say, we've got a plate heat exchanger there. We run water the other side, and so it then heats the water. So that's how it works. But why are we using them? Well, we're trying to get rid of fossil fuels. because of the damage which they do to the environment. Because this is absorbing free heat energy from the air, it's 3 or 4 times less harmful to the environment than doing the same heating with gas in that factor. Right, okay, so we've had a look at the science, we've had a look at the unit inside, and now it's time for your test.
All right.
Okay, didn't know you were having a test. I'm joking aside, but I just really want to know that you've understood it. So, go on, tell me how it works.
Well, the fan blows the air over the pipes.
Yeah,
The heat from the air goes into the refrigerant.
yeah,
And then the refrigerant goes into the pump,
yeah,
which pressurizes it
yeah,
and makes it hot.
yeah.
And then the hot refrigerant goes into the hot water.
Okay, yeah, perfect. So basically, we use heat transfer to absorb heat from the ambient air. We then use the compressor to pressurize it and boost that heat up. Evaporate the refrigerant, and we get really hot refrigerant, which then heats the water. The beautiful thing of it is that we put a small amount of electrical energy into the unit. It absorbs loads of free heat energy from the environment, and so it's 3 or 4 times less harmful to the environment than doing the same heating with gas. So this is why people are using heat pumps a lot more now.
All right.